Okay, here I'm going to talk a little bit about and show um, the how to physically communicate to the Rumba I create platform, and it can be exactly similar for the Turtlebot free platform. Um, if we take it from start, then we need here to have the settings for the PC's IP address known, and in the network file have the IP address updated, and in the PowerShell run this script here afterwards, and then open up the Visual Code Studio, create terminals here, and in one terminal we start the server, and before we start the server we have to be sure that the IP address, the server's IP address, must be set in the .bash HC file here in using a terminal, of course, and that for sure must be done before we start the ROS core, else it will not give us the correct address for the VSL machine. But when that is done, we start the ROS core. Then we take a PuTTY program and we connect to the Raspberry Pi, and we run the launch. Create launch file here is run by the statement. Where is the statement? It is here. ROS launch create bring up create to launch, and similarly for the Turtlebot free. Also here it is important, before we do that the bash file is updated with the correct IP for our PC. Seems to be working here, and it is serial link connected to the Raspberry Pi, and here we have the master URI, which must be set in the bash file here at the Raspberry Pi, using sudo nano and the .bash bashrc, and in the bottom there are two IP addresses you need to set correctly. The first one is the address for the PC, and the last one is the address of the Raspberry Pi. Now that seems to work, and we have created it, and then before we can write any program here to let it go in a circle or run in a square, we need again here to familiarize with what kind of topics and what types of topic. And if we browse up here in this terminal, then there is always an opportunity to use ROS topic list. Then we get a total list available publishing data out to the server. So this is what the ROS core on the PC responds back with through the network. And if we do the same over here, then we will also see the topics here. We can do it. ROS topic list. ROS topic list, and here we have it. And as with the turtle sim, we use the velocity together with the time for driving a certain distance. So command velocity here. The question is, of course, what kind of message type it is, because the message type must be known to in the code. Else the command topic will not work if the type is wrong. So there is in the cheat sheet here there is an Rust topic info, and this can be used actually to give us the type for the message. So if we try that out, and that can be done on either the PC or on the Raspberry Pi in a terminal, it doesn't matter. Oh, and a note here: if you are using the VirtualBox image, then you just have to do terminals outside in Ubuntu. Just create terminals, and in there do the stuff I do here inside the Visual Code. So we could say, I have it perhaps here, this topic type, and it is the command velocity. Then we have the type for the message here, and then we can see what kind of data by using the wash MSG on that one. Then we can see what kind of data types we need to have a show here, and then we have a listing here. You can see that we have the binary part here, just as the turtle sim. That's very nice. It's exactly the same, and the angular. So when we are going to do a circle, then we are going to have a constant velocity, radians per second here, as well as a constant x velocity. Then it will turn for a given time. Then it will stop afterwards. Or if you want to go into a square, we need to have this with a velocity, but then we need to have a time for which we have the velocity, and if we have the velocity and time and we multiply these two numbers together, then we have the distance. So the distance is equal to the velocity times t, the time, exactly as we did with the turtle sim. So that is actually what we would like here to work on to have it running physically. So we could try out here to create a new package actually for the create or Wumpa or turtle.free, same principle. So for that we need to go into Catkin workspace. We need to go into source, and then here we need to create a package with a given name. And again, the cheat sheet here can be used, because if we look here, then we have the it is here, so we have to use this, and the dependencies, yeah, that that is the Rush CPP and the standard message as we saw with the turtle, but we have to add that. We use the Rush wiki for that. So go back here. What was that? Q8. Funny. No. Wasp. Lad os lige se. Her var den. Catkin package. Catkin create package. Let's see if we get that over. Catkin create package. Create package. And then the name. It could be R for Rumba. Rumba square. It's quite good name for the package because then we get created automatically and CMake list file with the same C++ file in, so that's pretty smart to use the same name. Let's see if that is done, then we can, oops, so there was a name conversion thing here, which we have to try to fix, so we do it again, and then we get created another one. So this one I will delete. And then we have this one, and we go one step back, and then we say catkin make test this if everything is well. Oh yeah, we forgot the dependencies here. We have to fix that. Nah, then let's go back here to the source and into the package square, and let's see what's in here. Then we have the CMake list file and the package XML file, and let's go in here first because I think we should add a little bit from the turtle sim package here about the dependencies. Yeah, so let's have turtle was the package and the C list file is here, so let's start with having that copied into the other one. It is up here in the start, and it is not there as I forgot to have these parameters afterwards. So find packages required. This catkin find package with catkin required. Yes. So we simply rub that out. Now it's easy if we remember these parameters in when we create the package after the package name. Anyway, it is there now. I think that is the only thing. And let's see over here, there is perhaps also the need for, yes, here we also need to take parts from, we can see here the section here, we need to have that copy pasted as well over in the other XML file, because it has only the standard catkin. So we add this here. That's it. So let's actually go back again and try to rerun catkin to check everything is correct and understood. Seems so. No. Then next step is to go into the source. You see here, that was the turtle, the square here. There is no source folder. Let's close this. So there is no source folder, so we have to add the source folder here, src, and in the src file we have to have a new file which has the name s square. So r square, sorry, s square dot cpp. Then it is empty, and we have made something here in for the turtle. So if we use that here as a kind of template, then we can adjust it later on so it is fitting our needs. Perhaps it can be used directly. Let's see. Control Alt, Control C, and then we take it over here, the contents. Fact is that it is the same message type. So geometry message twist has to be included, so we can use the support from the library geometry twist. But command velocity is just command velocity. So that should be corrected, and else I believe it should be okay. So we have to save all here. Remember that in this environment we need to save all. Then we try to say catkin make. So we compile now the new package r square. I'm quite sure it will not do, because we need to add the executable in the make file, and that will not be shown here. So we need to redo what we did here, because it was in the bottom, more or less. No, it was up here. I said install catkin libraries. It's here. It's not there. It is here. That is the catkin packages. Yes. Where is it? We add the executable. We should add the executable. Add executable. Add dependencies. This means it is not included. We have to remove the hash time in front to include it. Where is this? Pretty hard to see all that stuff here. Strange. Here, this statement must be added, but it is there because it is not included, but we have to just to remove the hash time in front of it. Here, it's not add executable. This one. And we have to remove, we don't have any node in the project, and we don't have any node here, but else it is fixed. Yeah, so save to be included, I think, and sudden then it is similar to the other one. Catkin libraries must be supporting all the information about the ROS cycle. So it could make a difference. Yes, it did. So we have to remember to open this up, and then we have to add the executable here. So 136 we need to go down to in standard, and 149 always. Now let's see what happens. I need to stop the video now. Okay, here I will show actually another way to get into the Raspberry Pi for correcting the or manipulating the script to getting the robot moving. You can choose this icon down here, and then you can, instead of connecting to the VSL, you can connect to host, and then the host here is a new host, and it's called Pi @ and then the IP address Pi on the network, and it has to go there, and then I say connect. Now I remotely connect over an SSH from the Visual Code Studio, and you have to choose Linux here. Continue and enter password for the Raspberry Pi RASP. And then it installs a little SSH server, and that means now we have suddenly the graphically IDE for developing code on the Raspberry Pi available on our desktop machine. And from here you can, as in the VSL, use the terminals, and you have access to everything inside the Raspberry Pi over an SSH connection. So that's pretty good as alternative. As you saw earlier in this video, you have to open the program in an um, into a nano into the nano editor, and you have actually also the challenge to move code from the VSL machine to the Raspberry Pi. Everything can be done here as we have the two GUIs here, but we need of course to have another instance of the Visual Studio Code up here to have these two. You can see here we have the VSL connection and we have the SSH connection. If you are working in VirtualBox, then you should also be able to connect outside, of course, in Visual Studio Code, outside the VirtualBox through an SSH to the Raspberry Pi. That's very convenient. And then we can open the Catkin workspace. You see here we have the document and we have the source where our packets, and we were in the square, 1x2 thing. And we say OK for that. Then we can say the workspace. Perhaps you need to enter passwords several times. That can also be solved if you make a key, private, public key. And then we have here our source with the square file in, and if we open it, it is the code we copied from the Turtlebot, and we are going to adjust it as I said in the first part of the video. Now we have it graphically here. It's fantastic smart, and I can close this one, and this is the Raspberry Pi, and this is the VSL machine. So very, very, very convenient. Now it has to go straight forward, where velocity of 0.5 meter per second. I suppose that's pretty fast. And then it is going here. I think we should lower this a little bit, half of it. Then the other part here is where it is turning, and the question is here to adjust this, we can say code, so it turns correctly.